Ja, moin. Eigentlich ist sorry. The slot in the schedule is empty, at least on the printed one, but there's still something taking place today, so enjoy that there's so few people in here. You feel free to take a place, have enough space besides you, but I would like to start the talk. The problem is that my talk came in pretty late, just last week, because a different speaker couldn't attend, so they failed to put it into the schedule. But all you're here, I really want to welcome you with a very great thank you that you're here and you found me on the electronic schedule. So, so I want to talk about running virtual machines on Kubernetes today. My name is Fabian Deutsch, and I think that's what we can get started with. So, I've been in open source for good parts of my life, at least in the last 15 years or so. And in the last 7 to 5 years, I spent my time working on Qbert and Qbert. Both are virtualization-related projects. Qbert is a more traditional one, and Qbert, the one I'm speaking about right now, is a more modern one, which is combining Kubernetes and virtualization. I'm working for Red Hat, which is listed there. If you want to follow me, go to Twitter. I'm called Dumdida, and in GitHub, you can find me with Fabian D. Whenever there are questions, lift your hand or wait until the end. I'll be around. So, Qbert is about running virtual machines on Kubernetes. But Kubernetes is there to run containers. So why would you want to run virtual machines on Kubernetes if it's not intended for that? Yeah, that's a good question, because we already have solutions to run virtual machines, right? We have that good old OpenStack with the good old Qbert, and we've got other competitors in the proprietary landscape to run virtual machines on-premise, so in your own data center, or in the cloud, in a public cloud, right? The reason why we do that is because virtual machines have been around for 20 years, and Kubernetes and containers are coming along. But the old virtual machines, the old boxes, right, we have everywhere. We have thousands of them eventually in certain companies. They don't go away. So in reality, if you're going to a container age, then you will have your classical boxes, your literally fat VMs, right, which can have tens of gigs of memory and a terabyte of disk size and all the fancy stuff that VMs have. But on the other side, you're also asked or tasked to run containers with the same SLA. So you're asked to run it in production alongside the very old VMs you're having there. And we're speaking about really old VMs, right? So if we look back when all that virtualization stuff started, I just spoke to the VMware guys over there, and they said that VMware was founded like 22 years ago, so 1999. And since then, we've been building VMs. So what do we do with them? They don't go away. In reality, that means that people who are doing operations will have to maintain a virtualization stack. Well, they have it already, right? You bought it some time ago, you deployed OpenStack, you have a team now who's maintaining OpenStack, or you're using Ref, Qbert, VMware, Proxmox, and all the other tools and management tools which are out there to run your VM workloads, right? So usually the stack you're managing is on top, the VM workloads for your customers, for yourself, for developers, the VM platform, which can be OpenStack, VMware, or something else, on your bare metal nodes. Now, with containers, you then create a second stack, which is pretty much the same. Instead, the only difference is that instead of VMs, you're running containers. But you still have a platform to run the containers, which is Kubernetes, but Kubernetes needs to be run somewhere as well, right? So if you're running it on-premise, you might be running it on bare metal. Usually it's run in VMs, but that does not really change the problem, because the VMs in which Kubernetes is running also need to be maintained, and you need to have the knowledge, you need to have the resources to maintain these two stacks, right? And it's not only about network and storage. It's a lot to these stacks. The stacks are just not technical, right? But you need to maintain the knowledge and the people, all the tooling around it, configuring authentication, configuring metrics and alerts. What do I do if my bare metal server or my VM dies? All the stuff that is handcrafted around your stacks. Providing compute resources, called scheduling here in the slides, and providing network and storage is also duplicate, right? Because you need to provide it to your VM platform and to your container platform. And in the end, as said, you need the knowledge to maintain these two stacks. And this means you have not twice the money, but at least you spend a lot of money by maintaining these two stacks, which boils down to mostly knowledge, in my opinion. So that's where Qbert comes in. Qbert tries to address this problem of having these two stacks, these distinct two stacks where there's so few overlap in all the things I just mentioned. Qbert allows you to converge the infrastructure for containers and virtual machines. So how does it look? Symbolically represented here. So you effectively have your bare metal servers, and I highlight that here because in the past it was not so clear that Qbert should be run on bare metal, but it's intended for bare metal. So you have your bare metal servers. On top of that, you're running Kubernetes, and then you can use that Kubernetes cluster to run both VM workloads and container workloads. The benefit really is that you can use the same alerting, the same monitoring, the same RBAC, the same storage, the same network providers and infrastructure for both workloads. So there's really no difference anymore. And it's not just that we want to run the VMs as they are, but we also think that Qbert can actually help to move certain VM workloads over to the container world. So Qbert is also buying you time. That means you have VMs today, which you know you can break them up into containers, but it might take time because you have to sort out licensing issues, or you need to educate your developers or yourself to make that move from the VM world to the container world. And there Qbert is an escape hatch, because you can first take your VM and move it into the new stack, and then gracefully decompose it into a microservice if you want. But in reality, we know that certain VMs can just not be migrated to containers because they depend on custom kernel modules, or maybe it's just because it's too expensive. If you have an application that's 20 years old and you would have to rewrite it in order to fit it into a container, it might just not make sense to do that, right? Okay. By having the single stack, we now also have a convergence of the workflows and tools. So who of you has worked with Kubernetes before? Thank you for participating in this poll, and good to see that most of you have. So kubectl or kubectl is one of the favorite tools in the Kubernetes world besides the APIs. And after you are using Qbert with Kubernetes, actually kubectl becomes the tool of choice for both your workloads. So you can use kubectl to run your pods or deployments, replica sets, and whatever custom controller you have, but also to manage your VMs, right? So there's no difference. Kubectl is just an example here. This obviously is also true for all the API things, right? You can use your own client Go, or you can use your Python bindings, Ansible bindings to speak to Kubernetes. And these bindings can then be reused for VMs as well. If you're using Prometheus for doing metrics, you can reuse Prometheus. So all that and Prometheus alerts, for example, then they will apply to VMs as well. So that whole ecosystem that has grown around Kubernetes can be leveraged for VMs as well. All right, time for a demo. So some of the live demos went quite well, some didn't, so let's see how mine is going. As I stated early on, Qbert can run on nearly every cluster. There might be bugs, but in general, it should be really working in any cluster. I prepared Minikube. Who hasn't tried it should give it a try. So Minikube is actually running here. Qbert is running, API server running, all is good. What I now do is actually bring up our Qbert demo page, and we just go through it step by step. It's the Qbert demo. It's on GitHub. There will be links in the slide deck, which I'll be sharing later on Twitter. There's no special thing you need to do when starting Minikube, which is down here, except for you want to give it some more memory, because you'll be running VMs inside of Minikube, and if you, for example, want to launch Windows, you need 2 gigs of RAM, so give it enough. Usually the laptops and other machines have enough memory these days. It can take a while, that's why I prepared that. Important is that you use the VM, that you use a Linux box at best, right? Because it has KVM support. It also works on MacBooks. However, then the VMs are a little bit slower. But give it a try. All right. I start with this part. So here it says we need to install the Qbert operator. The Qbert operator is such a nice term. Actually, we can copy the whole thing. The Qbert operator is a small container which is just responsible for deploying Qbert. So Qbert is not a single container, it's actually composed of multiple containers. Qbert is implemented by using CRD, custom resource definitions in Kubernetes, which is a way to extend Kubernetes. It doesn't matter so much, but a few containers are required to make it happen, and that's what the Qbert operator will deploy. What we also see is some cluster roles are deployed, a service account is created, so pretty usual stuff. After the operator is deployed, scroll the wrong way, here we are. After we deployed the operator, we now want to deploy Qbert itself. So a few words on the operator. So the operator works by, that is the installer for Qbert. And now we need to tell the installer where do we want to create, where do we want to install, deploy Qbert, into which namespace. We've prepared a YAML for that, which is the YAML I highlighted in this line. And here we go. So qbert.qbert.io/qbert, and that's one of the best APIs and custom resource names. Anyway, it doesn't matter. Means that Qbert is now really getting deployed. We can actually check that by looking what pods are taking place. Oh yeah, so is that still readable? Okay, good. So we should have done that before. It doesn't matter so much. So one thing we see here is that all of Qbert is really just containers and pods and deployments. You don't need to modify the node. So Minikube is really stock Minikube. Well, we provided patches 2 years ago, which you don't know, in order to enable Qbert, but still, the node itself is not changed or configured. Everything we need, all the dependencies are delivered in containers. That's a benefit, because if we look at day 2, how do we do updates? Then Qbert is independent of the node itself. So you can really have your own application lifecycle for Qbert as an infrastructure component. What do we see here? So we're saying we're extending Kubernetes, and that's mainly done using the Vert API container, which is down here. That Vert API container is actually hooking up into the Kubernetes API server and then handling all your VM requests as they come in. Let's check. There should be some more. Oh yeah, the Vert controller. So the Vert controller is there. Once you have defined a VM, something should happen, right? If you usually just define a custom resource like a VM, nothing will happen if there's no controller. The controller is then responsible to take action upon the VM you defined. And we see, so I bridged the time very well because all of the pods are running nicely, and we can proceed to the next step. We have one client utility, which is called virtctl. It's down here. This is helpful for doing virtualization-specific actions. Like, for example, once we run a VM, VMs are different to containers to some degree, right? For example, virtual machines support live migration. Virtual machines support graphical consoles, which containers don't. So virtctl is actually a convenient wrapper around the Kubernetes API to provide you graphical access to the console, and for example, we have an RFE for that, to trigger the live migration. So it's a convenient wrapper, but all that functionality that virtctl provides is also accessible through the API itself. I've pre-installed that, so it should be here. It is. Great. You can actually use crew to install it as well. Now, everything is set. We have installed Qbert with 2 commands, installing the operator, setting up the CR, and Qbert is ready. So what we do now is we can actually take the following manifest to create our first virtual machine. So we see it's called VM YAML. We'll take a look at that in a second. So we apply it. Great, it's defined. So by the way, please notice it's kubectl, which we're using to create the VM. So how does it look? We're using kubectl edit to look at the definition of that VM. If we scroll further down, so there's all the regular stuff. We've got an API version, we've got metadata. That's just the usual player metadata from kubectl. We've got a name, we've got a namespace, UID, just the regular metadata you know from Kubernetes as well. Now we get to the spec. Now the spec is interesting because the spec here is specific to virtual machines. So pods have a pod-specific API and VMs have a VM-specific API. In this case, we have defined a VM which is not running. That's why we call it running with false. And we define a list of devices. So here we define a virtual device for the root file system and a virtual device to use Cloud Init. We could actually also skip the bus types to make it more dense. We specify one network interface. We're supporting multiple, including SRIOV devices, in case you want to use one. And then we define where the content of those disks is coming from. So here we're using a container, which contains the image for a VM. To boot that, it's a Cirrus VM. And we define a basic Cloud Init disk with Cloud Init data. Now, if we take a look at the VMs we have defined, we already saw we defined the test VM 93 seconds ago, and it's not running. So let's launch it. It's as simple as just changing that value to true. What a surprise. We edited the VM, and if you now check about the VMs, then we see that test VM is now running. We can verify that by looking at the pods. I mean, how do we run VMs? Just a short view on that. Qbert, one of the main goals of Qbert is to integrate nicely with Kubernetes in order to support what I said early on, right? To tie in with the monitoring, to tie in with the logging and auditing. So we had to see that VMs are transparent for Kubernetes and all the other tools which are built around Kubernetes. That means we're actually running the VMs inside of pods. That's not really crazy, it's just simple. So we can take a look at the pods, kget pods, and we see that a virt launcher was created. So virt launcher, test VM, and some random string at the end. That is now representing the running VM. To see that it's really running, we can now use virtctl vnc to look at the test VM. And here we go. That's the regular Cirrus test VM connected to via VNC running on Minikube on my laptop. There we go. So I don't know, we can do uptime. We're up for less than a minute. We should have 64 megs of RAM. Let's see. Yeah, 44 megs of RAM. So that's it. I mean, we used an image of a VM, a QCOW or raw image, and we just started the VM by defining it and launching it. We can now disconnect. Nice, and we can actually try to connect via the console. So that I just connected to the VM using VNC, but you can do the very same if the guest is supporting it using a serial console by using virtctl again. And here we are. How do they actually have OS release? Oh yeah, they have. Great. So it's they don't even say their name. That's not really polite. Never mind. So that's it to connect to the VM. What else can we do? Oh yeah, it's running. So it's running. It's consuming resources. Just like you can do with pods, like setting resources, resource requests and limits, you can do the very same with VMs. So the amount of memory the VM is currently consuming in the cluster, 64 megabytes of RAM, Kubernetes is accounting that. So it's taking that out of, that is completely recognized by the scheduler, which is important because we obviously want to run pods and VMs side by side, and so we need to do the accounting right. Otherwise, we'll overcommit a node. Good. What we can now do is actually stop the VM again. We can use actually virtctl for that. It's as simple as saying test VM. The VM was scheduled to stop, and if we now look at the VM, then we see that virtctl actually did nothing else than just changing the running to false again. No magic. Good. After defining it, we stop the VM. We can actually delete the VM. I mean, there is nothing special to it. If there's no further question to the demo, I would actually switch back to the slides. Any specific question right now, which I can show here? Great. Then let's go back. You can do the demo yourself by following the link down there. Great. So I can already wrap up. So what we want to do is we really want to be simple and integrate nicely with Kubernetes. So that's why we are able to just drop Qbert into any existing bare metal cluster. You can actually also, for a CI purpose or for testing purpose, actually do it in emulation or nesting mode in the public cloud. So you can actually deploy that on AWS or Azure as well, but it would not run production workloads there. So, but for CI, it's actually pretty nice because in those VMs you can run Windows, you can run, all the operating systems which are down there. So in case you're running testing for agents in different operating systems, Qbert might be fit for you. We showed that kubectl can be used to rule them all, containers and pods, and VMs, obviously. The same resources, so storage network and the computer resources are used to both pods and containers, and there's no node configuration needed to make Qbert run. If you want to learn more about Qbert, then you can go to github.com/Qbert. You can join our mailing list. We'd love to see you there. We have nice cat pictures and nice stories to tell. Join us on Slack. We're on Kubernetes Slack, or join our weekly community meeting in case that you want to show off something or have a question. There's even more going on, which I didn't add to the slides. One interesting thing two interesting things I would like to mention to you are actually the work we do on having, let me see, where did I provide that? Is that we have two interesting projects which build upon Qbert. One is actually UI, which you can use to do all the virtual machine lifecycle management, so to create them, to import them actually from different virtualization management platforms like VMware. So there's a dialog, and you can select your vCenter, and you can then import it into Qbert. In the web UI, you can actually connect to the graphical console to do your administrative stuff. You will find that actually on our GitHub page as well. The other interesting thing that Lutz is doing is actually they're using Qbert to bring up Kubernetes clusters. So they spawn a number of VMs and they intend to run Kubernetes on bare metal, deploy Qbert, and then use Kubernetes to actually create more VMs, which are then running a nested cluster for hard multi-tenancy. So you have your own cluster, your own separated cluster from the undercloud in Qbert VMs, and you use Kubernetes to manage it. So you can give that to your tenants or to customers for whatever use case they try to address. So these are two interesting things. We also have cloud provider support. So if you're running a Kubernetes cluster on top of Kubernetes, then you can actually install a cloud provider in the upper Kubernetes to control the underlying Qbert instance, for example, to scale the cluster up or introspect the underlying cluster. That was provided by the community. All right, way in time. I thank you very much, even for being here, even if it wasn't announced. Yeah, thank you very much.